Most discussions about omega-6 fatty acids paint them as inflammatory villains to be minimized. But there's a specific omega-6 found abundantly in eggs and poultry that plays a surprisingly important role in muscle protein synthesis, particularly for older adults trying to maintain or build strength. It's called arachidonic acid, and the relationship between inflammation, exercise, and muscle growth is considerably more nuanced than simplistic, anti-inflammatory narratives suggest. Arachidonic acid is involved in signaling pathways that trigger muscle protein synthesis, especially in response to resistance training. This might sound counterintuitive if you've been told all inflammation is bad, but exercise-induced inflammation is actually necessary for muscle adaptation and growth. The inflammatory response to resistance training is what signals your body to build stronger muscle. Completely blocking this process with anti-inflammatory interventions can actually impair training adaptations. Research on older adults has shown those with higher arachidonic acid intake maintain better muscle mass. Some studies on resistance training combined with arachidonic acid supplementation or high dietary intake show enhanced muscle growth compared to training alone. The effects appear modest, but potentially meaningful for populations fighting sarcopenia. Eggs, particularly egg yolks, are the richest common dietary source of arachidonic acid. Poultry, especially chicken and turkey, also provides substantial amounts. Red meat contains some. Fish and plant foods contain minimal arachidonic acid. For someone consuming several eggs daily and regular poultry, arachidonic acid intake is likely adequate. For those avoiding these foods, intake may be insufficient to support optimal muscle protein synthesis signaling. Now here's where the timing matters. The post-workout period, roughly within 2 hours of resistance training, appears to be when arachidonic acid intake is most beneficial for muscle protein synthesis. This makes sense mechanistically. You're providing the signaling molecule when your muscles are primed to respond. Practical implementation might involve eggs or chicken in your post-training meal. The inflammation concern requires direct address. Yes, chronic systemic inflammation is problematic and associated with various diseases. But acute, localized, exercise-induced inflammation is beneficial and necessary for adaptation. The goal isn't to eliminate all inflammation, but to support healthy inflammatory resolution after appropriate inflammatory signaling. This is a critical distinction that simplistic, anti-inflammatory everything advice misses. For older adults specifically, the challenge is that age-related anabolic resistance makes muscle building harder. You need stronger signals to trigger the same muscle protein synthesis response you'd get when younger. Arachidonic acid appears to help provide that stronger signal, particularly when combined with adequate protein and leucine intake post-exercise. Supplementation with arachidonic acid has been studied, typically at doses around 1 to 1.5 grams daily. Results are mixed, with some studies showing enhanced muscle growth in trained individuals, others showing minimal effects. The supplement form appears safe short-term, though long-term data is limited. I generally favor food sources over supplementation, but for serious older athletes or those with very low dietary intake, supplementation might be worth considering. The resistance training context is essential. Arachidonic acid isn't going to build muscle without the training stimulus. You need to be doing actual resistance exercise that creates the inflammatory response and muscle damage that triggers adaptation. The arachidonic acid supports the process, but doesn't replace the work. There's also the balance to consider. While some arachidonic acid supports muscle growth, excessive omega-6 intake relative to omega-3 might contribute to unhealthy inflammatory balance. The key is adequate arachidonic acid from whole food sources like eggs and poultry, combined with sufficient omega-3s from fish, while avoiding excessive refined omega-6 oils from processed foods. What I find interesting about arachidonic acid is how it illustrates the complexity of nutrition beyond simple good-bad categorizations. Omega-6 fatty acids aren't uniformly inflammatory and harmful. Specific omega-6s like arachidonic acid, in appropriate amounts from whole food sources and properly timed around resistance training, may actually support muscle health and function in aging populations. This requires moving beyond simplistic thinking toward nuanced understanding of context, timing, and dose.